All right, let's talk about Java security. Today, we're going to dive deep into how to transform your Java applications, taking them from having potential cracks in their armor to being absolute digital fortresses. So, where do we even begin?
Well, this is a great place to start, right? I mean, think about it. The biggest names in finance, the giants of e-commerce, they build their entire empires on Java. There's this deep, fundamental trust in its security architecture. But, and this is a big but, that trust doesn't mean we can get lazy. The stakes are just way too high.
And this quote just hits the nail on the head, because Java is so central to these high-stakes industries, its security isn't just some nice-to-have feature. Nope, it's the bedrock. It's the absolute foundation that so much of modern digital business is built on. So here's our game plan. First, we're going to find those cracks in the armor. Then, we'll look at how attackers actually exploit them. After that, we'll cover Java's own built-in defenses, and finally, we'll get into the toolkit you need to build a truly impenetrable fortress.
Okay, first up, the cracks. Now, these aren't always flaws in Java itself. A lot of the time, they're common oversights, simple things we do as developers that can weaken an application's defenses from the inside out, long before any attacker ever shows up.
You know, what's wild about this list is how basic these issues are. Just failing to update your Java version, that's leaving the front door wide open to known attacks. Not using the principle of least privilege, that's basically giving an intruder the keys to the whole kingdom if they manage to get in. And oh man, those third-party libraries, they save us so much time, but they can also be a Trojan horse if you're not constantly checking them for new vulnerabilities.
All right, so we've seen how we can accidentally leave gaps in our own defenses. Now, let's flip the script and look at the external threats, the specific ways cybercriminals hunt for and exploit those very cracks we just talked about.
These numbers from Statista, they really paint a picture, don't they? SQL injection and cross-site scripting, or XSS for short, these aren't just some abstract risks. Together, they make up a massive chunk of the most critical vulnerabilities found in web apps today. So let's break down what they actually are.
The key to understanding SQL injection is realizing it all comes down to an application blindly trusting whatever a user types in. An attacker can write a special bit of code into a search box or a login form that tricks the database into running their commands, potentially dumping out all of its most sensitive data.
Now, XSS is a little different, a bit sneakier. It targets the end user, not the server directly. An attacker injects a malicious script into a website you trust. Then, when you visit that page, the script runs in your browser. It can steal your session cookies, your login info, or even send you off to a phishing site.
And of course, the list goes on. Attackers are always looking for ways to hijack user sessions or to find sensitive data that wasn't encrypted properly. They'll take advantage of servers that are misconfigured with default settings, or they'll even try to trick a logged-in user into doing things they don't want to through something called cross-site request forgery.
Okay, so that all sounds pretty scary, I know. But here's where the story takes a turn, because Java wasn't built to be a sitting duck. It was designed from the ground up with security baked right into its DNA, with a whole set of powerful defenses ready to fight back against these threats.
So, let's explore Java's native security architecture, the stuff that's built right into the platform, working to protect your applications straight out of the box.
This brings us to one of Java's superpowers, the sandbox. The Java Virtual Machine, the JVM, is basically a secure container. It can run code you don't fully trust, like a third-party plugin, but it puts that code in a little box, isolating it and cutting off its access to your file system or your network. So even if the code is malicious, the sandbox keeps the damage contained.
And here's another absolute game changer. In languages where you have to manage memory yourself, it's easy to make mistakes that open up huge security holes, like buffer overflows. But Java's automatic memory management, it handles all of that for you, behind the scenes. It's like a safety net that prevents entire classes of memory-based attacks from ever even being possible.
And on top of that, Java gives you this incredible layered defense. You've got the security manager, which acts like a bouncer for sensitive operations. The class loader is your gatekeeper, making sure malicious code can't just sneak its way in. And the Java cryptography architecture gives you a powerful, standardized toolkit for all your encryption and digital signature needs.
Now, Java's built-in defenses are a fantastic foundation. They really are, but they aren't a silver bullet. To build a true fortress, you need to reinforce that foundation with the right set of dedicated security tools.
This table really shows the modern security philosophy in action. It's not about running one scan at the very end and hoping for the best. It's about building security into every single step. You need dependency scanning for all the code you didn't write. You use static analysis tools like SonarQube to find flaws before your code even runs. Then you use dynamic analysis with tools like Burp Suite to poke and prod your live application just like an attacker would. And finally, you automate your dependency updates with tools like Renovate, closing security holes before they become a problem. This is the heart of a DevSecOps mindset, making security a constant, automated part of how you build software.
And if there's one thing you take away from all this, it should be this right here. The programming language is just one piece of the security puzzle. Real-world security depends on us keeping our components patched, configuring our systems correctly, and writing secure logic. It's a shared responsibility between the platform and every single developer.
So at the end of the day, what this all really means is that security isn't some feature you just add at the end. It's not a checkbox. It's a process. It's a continuous cycle of being vigilant about new threats, constantly testing your defenses, and weaving best practices into every single thing you do.
And that brings us to our final question, and it's one I want you to take back to your own projects. Look at your dependencies, your code, your configurations. Is your application's fortress truly secure? Or are you just relying on the strong walls Java provides without actively manning the watchtowers? Thanks so much for joining me.